Consider the quadratic function f of x equals 9x squared minus 9. So we need to find the vertex, x value of its largest x-intercept, y value of the y-intercept. So I think the hardest part for students on this one is to find out what is the vertex. So if we look, the standard form for the quadratic function in vertex form is this: a times x minus h squared plus k. So we can see the plus k out to the side, but it's hard to see the x minus h squared. However, what if we wrote it like this? So 9 times x minus 0 squared minus 9. It's a little easier to see there. We can put that 0 there and it doesn't change the value, but it does tell us that our x-coordinate of the vertex is 0. So we'll have 0 for the x-coordinate, negative 9 for the y-coordinate. It's kind of similar if we had a line that was y equals 2x that we had to graph. Well, it's tricky to see that, but if we add on the plus 0, we can see, oh, that's just a line in slope-intercept form, and I know how to graph that. So sometimes throwing that 0 in as a placeholder kind of wakes our mind up, so we're like, oh, I see what's going on. Okay, x value of its largest x-intercept. So we need to find the x-intercept. Now, if you remember, the x-intercept is where y equals 0. So we're going to need to solve this, 9x squared minus 9, and set it equal to 0. So we'll add the 9 on both sides. So we get 9x squared equals 9. Divide by 9 on both sides. So we'll get x squared equals 1. Now, to find x, we need to take the square root. However, when we take the square root like this, we have to put on a plus or minus. We have to consider both the positive and the negative case. So x equals plus or minus the square root of 1, or plus or minus 1 after we take that square root. Okay? So to see that in more detail, just plus or minus square root of 1, the square root of 1 is 1, and then it's the positive 1 and a negative 1. You could also write this like x equals 1 and negative 1, although I think it's quicker to write plus or minus 1. So they're looking for the x value of the largest x-intercept. In this case, it would just be a positive 1. Now the y-intercept is a little easier because we can see our vertex was at 0, negative 9, and so that is where our y-intercept is. So it's just going to be negative 9. But similarly, you can say, well, I know my y-intercept is where x equals 0. Substitute that in and solve, which we'd still get negative 9. So there you go.